We've all heard of the T app, you know, that women's only app that allows you to talk about men. Did you know about TeaOnHer, the men's only equivalent? And it turns out that they copied everything from the T app, including its bad practices and its terrible security flaws. I saw an article on TechCrunch about the exposed web access, the unsecured authentication, and the exposed images. And I thought, I've got to dive into this. I've got to see if it's true. And it turns out it is. So we're going to get to that. I'm going to show you what you can access, what data is leaked, and how to see somebody's ID. Might not show you their ID, but I'll give you the concept. This is just as bad, or if not worse, than the original. Let's talk about what's actually happened. So TeaOnHer is a dating app that appears to have essentially copied every single thing about the original T app. So this is the original T app, allowed you to do these things. You could sort of like live talk about whether you've met this person before, give a review, all of that sort of stuff. Well, TeaOnHer is basically the same thing just for the women. And I'm guessing it's vibe coded. It screams vibe coded when you look at how it's working. You'd think given the catastrophic design of the original T app, they would have worked on that and improved it. So what are TechCrunch saying has happened? TeaOnHer, a rival T app for men, is leaking users' personal data and driving license. But first, a bit of history about the T app. If you're not familiar, I do have a whole video about that. It didn't do very well, so go watch that one if you're interested. But essentially, the T app leaked all of the users' data by allowing the images to be publicly exposed. So this is one of the URLs that you can find in the code on the TeaOnHer app. This essentially allows you to download any person's user image, and we'll get to how I found this in a moment. But essentially, this is what you need to know about the image. So you can see here that we've got this path for CloudFront. That probably means it's storing it in S3, which I would imagine on AWS. Then you've got review images. This is a folder. And then we've got a date structure, which I'm guessing corresponds to the upload time of the image. Then we have this string here. This is the user ID. So this is just the ID of the user posting the photo, which if you can get somebody's ID means that you can essentially just look at this, because the next part of the URL, it's exposed in an index page. So you can see all of those if you know a user's ID. Not that that really matters, because you can just look up everybody in the app with one request. We'll get to that. But yeah, then following that, you've got this URL. They seem to be setting all images to JPEG, regardless of what the image is. So my guess is this is some sort of standard URL format. It's the user ID, a random ID, .jpeg. They're not actually checking the file type that is the image. TechCrunch are claiming they've also identified secondary security risks with email addresses and passwords in plain text belonging to the app's creators. And I have found them, and I'm going to show you them in a moment. Were left exposed on the server? They really were. This is bad. The credentials appear to grant access to an admin panel. The credentials do appear to grant access to an admin panel, though the admin panel does not appear to be public from what I can see. As an app developer myself, I often have to debug these sort of situations. So I did the classic that anybody does. I got open a proxy using Proxy Man, and I had a look. I downloaded the application, I opened it up, and I saw what web request it was doing. I created an account because I thought, why not? I didn't actually upload my ID and password, so I don't expect to get verified. But I saw that it's going to this appserver.teaonher.com. I thought, perfect. We're going to look that up. So I took my app server URL and I did what any respected searcher does, and I Googled it. Why would you do anything else? So I Googled it and I saw this Cloud Documents TeaOnHer API backend page. I thought, what's all this about? I clicked on this and I saw this. This isn't part of TeaOnHer's app, but it is data that they've exported from there. This is actually a JSON structure that you're seeing from their URL. And I'll show you that live in a moment using the Wayback Machine. But you can see here it's talking about the features available in the app, which is mail ID verification, review management for violating terms and conditions, advanced search, user statistics, real-time notifications, guest user reporting system, all that sort of stuff, S3 file storage. Then below that, we see some URLs. These are important. So we've got the docs. They don't appear to exist. That URL does not appear to exist. When you go to appserver.teaonher.com/docs, nothing exists, nothing appears. But if you go to /health, you'll immediately notice that there are some health parameters reported. So we can get a bit of an understanding. We can't gain much from this, but we know that it's got a database and it's connected. It's got a response time and that the API is running and is optimized for high performance. whatever that means. But your question is probably, where did they get this information? Well, this information appears to exist on the root of that domain. If you go to appserver.teaonher.com without any URL, you now get status healthy. But previously, back when the app was being built, if you go back on the Wayback Machine to TeaOnHer back to the 12th of August, you'll immediately notice the response is JSON. And this is what we're looking at. We've got all of the information as well as some clear text passwords and usernames. So whoever Lampikin is, his email address is now public. And so is his password of the very secure password, capital P, password 1. That's a great way to go, isn't it? It's quite interesting because here we can understand quite a lot of the flow of the application. So these are our endpoints. Some of these require authorization and an account on the system to view stuff, but we can get an understanding that the verification flow is we're going to submit some details, we're going to check on the status of our details, and we can create a test. I don't know what a test is, but we can create a test. For uploading images, it appears to just post to /images. Okay, so now we have a bit of an understanding. How can we leak their data? How can we see what is going on in the T app without using it? Well, let's go back to that web request we looked at earlier. What you'll notice here in the outbound headers and stuff is anything to do with actually validating the application. So we have got a user agent header set as the Truth Talk app. I think that's what the app is actually called in the back end, but I'm not really sure. But this is all that's being said. No sort of cookies, no request headers, none of that sort of stuff. No authentication at all. So, well, knowing that and knowing what we know here, we're going to try and hit some of these URL endpoints and see some data. Let's go with the reviews. Given we know the review URL is API v1 reviews, I've got my URL here. We're going to go /API v1 reviews and send. Oh, that's everybody's data. Oops. Don't worry, that can't be everybody's data. We can't have all of the information, can we? So what have we got here? We've got an ID for the post, that is this. We've got review ID, so this is the user ID, and as you can see, it matches with the URL parameter. And then we've got the subject name, the subject's age, the subject location, title, content, review type, positive. Oh, this person likes this person. The created date. So with the created date, of course, we could work out the image URL and view count. These are all the information you're going to want to know about the post, who posted it, and announcement priority and some other things. And there's quite a lot of information. We've got that for, I don't know, 20, 30 users. When you get right to the bottom, it tells you that per page, we've got 20 users. Okay, but don't worry, we don't know how many pages there are, or do we? We know here that we've gone page 1. I wonder if we can change pages to see page 2. It turns out that as easy as putting page 2, we can now see page number 2. But now that we've successfully exposed all of the data in the app, I'm sure some of you will be interested in. So why are these apps built so poorly these days? And I think it comes down to vibe coding and AI. I'm guessing a lot of this app is built with AI. And most iOS or app developers, they tend to sit quite far that way on the spectrum of back-end server-related contents. They don't interact with that much, and they kind of think the communication pipeline between your app and the server is secure. People can't access it, people don't know what's going on. Well, that couldn't be further from the truth. I think this is a great example of why the new Online Safety Act in the UK is a terrible idea. Because actually, all that data is just going to get leaked at some point. I know they might be spending more time on it, but at some point, that data is going to get leaked. But I just thought I'd do this to show you what is going on with the TeaOnHer app, how to access some of this data, and how not to get hacked. Anyway, I'll see you in the next one.